This is the last lecture for the acid derivatives, and we're now ready to do some synthesis problems because you have now learned all the reactions that involve acid derivatives. All right, your book has an awesome figure. This is figure 21.11 from your book that I copied, and I love the way they organized all the reactions that you're supposed to know. And the reason is that, notice in the bottom line, this is the oxidation level 1, so you have the alcohol and the amine. And then as you go up, the oxidation level is going higher. This is oxidation level 2, the aldehydes. And then all these are same oxidation level, which is 3. Now carboxylic acid should be in the same line here, but because of the space they put it up here, but all these are oxidation level 3. So as you go from bottom to top, the oxidation level is getting higher. But not only that, as you go from right to left, so this is the most reactive, acid chloride and anhydride, followed by ester, amide, and then nitrile. Okay, so you see all these arrows that you have, that is going from one compound to another. You basically have to know all these transformations in order for you to be able to do synthesis. So your first job before you do synthesis is commit all these reactions to memory, and I hope that you were doing this as you were taking notes and studying and doing the problems over and over again and making note cards. Probably, I think that's the best way to memorize reactions. As I've shown you before, you should have forward and backward reactions. So in the front of the card, write down, for example, the carboxylic acid with H plus and an alcohol, and then in the back of your note card should have an ester in there. And then ask yourself, quiz yourself, how do you make esters? And that will be one method. All right. So once you have all these memorized, notice that these are basically functional group transformations, going from left to right. When you go up and down, you're changing in oxidation state. And the other type of conversion that you need to know is the carbon-carbon bond formation. And we've gone over this. So in a synthesis problem, if you know that you have to make bigger molecule, you have to make a carbon-carbon bond somewhere. So one way is Grignard, as you know, makes carbon-carbon bond formation. And by the way, this is shown in table 21.2. I'm just summarizing. You could do cuprates to make carbon-carbon bond formation, and you could react with cyanides. So like sodium cyanide plus some kind of alkyl halide, you can make a carbon-carbon bond formation. All right, so functional group transformation and then carbon-carbon bond formation. Between those two things, you should be able to do all the synthesis. All right, so let's do some examples. I'm going to try to squeeze in as many examples as possible, and if need be, I'll have another lecture going over some of the typical problems. All right, so this question is: synthesize ethanoic, propanoic anhydride from 2 or fewer carbons with oxidation level of 1. So you should draw out the product that you are supposed to make. So obviously you need to be able to draw this ethanoic, propanoic anhydride. And the constraint is 2 or fewer carbons. All right, so the ethanoic, there's 2 carbons. On the propanoic, there's 3 carbons. So at some point you need to make carbon-carbon bond formation. But probably the best way to tackle the synthesis problem is to go backwards. So draw an arrow pointing to it. So, and then ask yourself, how do I make, what is the functional group here? It even tells you anhydride. So how do I make anhydrides? That's the question you should be asking. And you should have in your head that anhydrides could come from either an acid chloride or from a carboxylic acid. And so for most of the acid derivatives, you know that the acid chloride is the most reactive. So you know that all these other functional groups be made from acid chloride. So that's probably the easiest thing to remember, is that you can make it from acid chloride. So then your question is, which acid chloride? It really doesn't matter in this example, all right? So we will have this acid chloride and this alkoxide, because you need a nucleophile to make the anhydrides, right? So then this makes the anhydride, and then this basically becomes two new synthesis problem, all right? Until you've satisfied the limitation, which is 2 or few carbons with the oxidation level of 1. So then you draw another arrow to it, okay? And ask yourself how you would make acid chlorides. You know that you make it with thionyl chloride from carboxylic acid. So this is what I mean by knowing the reactions and having them at your fingertip. All right. So then we're not done with this yet because this is not 2 or fewer carbons with the oxidation level of 1. So how do I get carboxylic acids? You know that you could oxidize from alcohol with a strong oxidizing agent. So for example, chromic acid would do it. So you have from alcohol to carboxylic acid. So this right here is what I'm doing here, the oxidation going all the way to the acid, all right? So notice that now satisfy the limitation of 2 or fewer carbons with oxidation level 1, all right? So as far as you're concerned, like when you are imagining making this in lab, this is what you would do. You will buy this. Whatever the limitation is, you're pretending that's what you could buy. So you buy this from Aldrich, ethanol. You're gonna, week 1, oxidize it with chromic acid, or sodium chromate, the same thing. And then, so you get an acetic acid. And then from acetic acid in week 2, you react with thionyl chloride and you make this acetyl chloride, right? Meanwhile, your partner has made this for you. So then you combine those two things to make the anhydride, okay? So this other reagent that you need, your lab partner is now working on it, right? So then your lab partner says, oh, how do I make this acid salt of propanoic acid? You need to start from the acid itself and use some kind of base like sodium hydroxide, potassium hydroxide. It doesn't matter what the base is, right? So once you have a good nucleophile, good nucleophilic nucleophile, well, repeating myself, this with the anion, then this reaction happens a lot more readily. So then this is the same problem as what you've had, right? So you have the oxidation with chromic acid to get to the acid. But your lab partner has a problem in which she has to keep working on it because you can't get 3 carbon because the urine limitation is 2 carbon. So this is where carbon-carbon bond forming reaction will have to be used. And since you have an alcohol as your product, your first thought might be to use Grignard reaction because it produces alcohol directly, and So if you have an aldehyde, formaldehyde with this carbon right here, and then you react it with 2 carbon long Grignard reagent and treat it with acid, you make this propanol, right? And since this is 1 carbon, you satisfy the number of carbons, but it's not at an oxidation level 1, so you have to show that you could make that from methanol. And now you need a weak oxidizing agent because you're only going to the aldehyde. Meanwhile, you would also make the Grignard reagent from the magnesium, from the ethyl bromide, and that would be oxidation level 1, so you're all now completely done. All right, so this is how I would do it, rather than trying to come up with the starting material way back here and trying to figure out the dots to get to here, to the product. I would just go 1 step at a time backwards, and then if it requires a double synthesis of 2 different reagents, then just take 1 reagent at a time and go down to the requirement, and then tackle the other problem as if this is another synthesis problem. All right, so basically your lab partner would be in the lab for a couple months, because she would start with ethyl bromide, make the Grignard reagent, react with formaldehyde, which she worked on it by oxidizing from methanol, and then she would get the propanol, oxidize it to propanoic acid, and then deprotonate that proton to make this nucleophilic acetate. I mean propanoate. And that will be the synthesis of that first problem. All right. The second one is synthesize ethyl propanoate from 2 or fewer carbon alcohols. So let's draw that out from the name first. CH3, CH2, C double bond O, O, CH2, CH3. And once again, we need to go down to 2 or fewer carbon alcohols. So again, recognize the functional group. This functional group is ester. All right. And you know there are many ways to make ester, so you could do the same way that you did here, in that you draw an arrow to it and ask yourself how I make esters, and you could make it from carboxylic acid, with the appropriate alcohol, which would be this. And you need an acid catalyst to do that. So that would be an esterification reaction, or if you chose, you could have done an acid chloride way. All right, so either way it will be acceptable. All right, so then you would keep on going backwards again. All right, so I'm going to stop here and continue this in the next video.